Hey guys, welcome back. So far we've been talking about the neurons and all the physiological event that occurs on a single neuron. Now it's time to take a look and appreciate that these neurons work together to actually accomplish their feats. This is called neural integration. It's important to realize neurons do not work alone. Instead, they work in groups, with the smoothness directly related to the neural integration via the neuronal pools. A neuronal pool is a group of neurons that process and integrate incoming information received from other sources and transmit this information to other destinations. These neuronal pools have zones associated with them. One of them is called discharge zone. Now, the discharge zone has the neurons that are most likely to generate impulses, being the neurons closest associated with the incoming fiber. You can see them here represented in the cream-colored area. Notice they are the ones that are closest to that neuron. Notice on the perimeter, though, we have another set of neurons, and these neurons are called the facilitated zone neurons. These neurons are further away, and they are less easily brought to a threshold by an incoming impulse, but are facilitated, allowing them to be easily brought to threshold by another source or a stronger stimulus. So these are the ones that are going to take a little bit more strength of stimulus to encourage. Now these neurons also work in circuits. There are several types of circuits, the first being diverging. Diverging circuits amplify, are also called amplifying circuits, that result in many pathways being activated by one neuron. Now notice here, a good example of that would be a single neuron in the brain can activate hundreds or more motor neurons in the spinal cord and thousands of muscle fibers at one given time. A converging circuit, though, is going to be one in which we see a number of inputs coming in and a single pathway going out. This would be an example of a sensory stimulus that can elicit the same memory. That would be tasting a donut versus smelling a donut versus just seeing a donut shop. Can all bring back a memory of the pleasure of eating a donut. Oscillating is also known as reverberating circuits. Notice here what we see is we're utilizing a positive and collateral synapses controlling rhythmic activities such as breathing. Notice we have this feedback going on. A neuron that is fired also feeds back and fires on a previous neuron, so that we have a reverberating kind of approach occurring. These are most commonly found in rhythmic type of activities such as sleep and awake, and repetitive motor skills such as walking and talking. And then we have the parallel after discharges. Now in the parallel after discharge, notice that we have a signal stimulates the neurons around a parallel array that eventually converge on a single output. Now an example of this would be, or may be, involved in exacting mental processes such as mathematical calculation. I like to think of this one as the aha circuit, because this is the one where the light bulb comes on. All of a sudden you have a variety of different stimuli coming in, discharging over and over again until we get this burst of impulse. And finally, these neural pathways can have patterns to them in the neural processing. The patterns can either be a serial single pathway or a parallel series of pathways. Now, a single pathway is going to be most commonly found in things such as reflexes. They're going to be quick, autonomic responses to a stimulus, where a particular stimulus always evokes the same response. Many times we think of this as an innate response. Parallel, on the flip side, is going to have a single stimulus sent down many pathways, dealt with simultaneously along each pathway. This allows you to have a series of thoughts or responses from a single stimulus. Now, where could this be factored in? Well, this could be something as simple as smelling the turkey on Thanksgiving, having you to have a series of responses coming from it, such as the warmth of family, the warmth of the home that you normally eat in, and or making your mouth water because you remember what that turkey typically tastes like. I hope you enjoyed neuroanatomy and neurophysiology. Y'all be safe. See you soon.